Welcome to the Web Security Bootcamp channel, a series of SQL injection tutorials. In this video, we're going to walk through a PortSwigger lab where we use SQL injection to explore and extract data from an Oracle database. This is part of a beginner-focused series, so I'll explain each step clearly, not just what we're doing, but why it works. We'll be using union-based SQL injection to enumerate the database structure and retrieve sensitive information. And as always, this content is for educational purposes only. Only test these techniques in labs or systems you're authorized to assess. This lab contains a SQL injection vulnerability in the product category filter. When we select a category, the application sends that value to the server as a parameter, which is then included directly in a SQL query. Because the results of that query are reflected back on the page, we can manipulate it. This allows us to use union select to retrieve data from other tables in the database. Our goal is to find the table where usernames and passwords are stored, then find the administrator user's password and log in with it. Before jumping into the lab, here's the strategy we'll follow. First, we confirm that the input is vulnerable to SQL injection. Then we determine how many columns are returned by the original query and which of those can display text. Once we understand the query structure, we move on to enumeration, starting with listing tables using Oracle System Views and then identifying the relevant columns. Finally, we extract sensitive data from the most useful tables, which will allow us to log in as the administrator. Let's start testing. I turn on Intercept in Burp Suite and click on the Toys and Games category. The request is intercepted, and I send it to Repeater so I can work with it safely. Then I turn Intercept off and go to the Repeater tab. First, I send a regular request without modifications to observe the application's normal behavior. The server returns 200 OK, which means the request is working normally. Now I want to test whether the application is vulnerable to SQL injection. I add a single quote to the category parameter and send it again. This time I get a 500 internal server error, which usually means the SQL query broke. To confirm this, I add a comment using -- to ignore the rest of the query. I send it again and now I get 200 OK. This shows that we can control part of the SQL query. Next, I try a union query. I use this payload, single quote union select null from dual --. Since this is an Oracle database, I use the dual table for testing. I encode the payload and send it. The response is 200 OK, which tells me the query has 2 columns. Now I check if these columns can show text. I change the payload to single quote union select a BC, DEF from dual --. I send it again and get 200 OK. That means both columns support text, and we can use them to extract data from the database. Now I open the official PortSwigger SQL injection cheat sheet and go to the database contents section. Here, PortSwigger shows which queries can be used to view database contents in different systems. In our case, the database is Oracle, so we focus on 2 queries. One to list tables and another to list columns inside a table. Now let's use this to build a payload that lists the tables. In Oracle, all tables is a system view that contains information about available tables. It includes a column called table name, which stores the names of those tables. Since we only need table names, we don't use select star. Instead, we select just table name. Also, we already know the original query returns 2 columns, so our union select must return 2 columns as well. That's why I use table name as the first column and null as a placeholder for the second. This gives us the payload, single quote union select table name null from all tables --. Next, I want to find the columns inside that table. For that, I use the second query select all from all tab columns, where table name equals the name of the table we found. In Oracle, all tab columns describes the columns of the tables available to the current user. This view has table name, that is, the name of the table, and column name, that is, the name of the column. Again, we only need the column names, so I select column name instead of using star, and I keep null as the second column to match the required structure. This gives us the payload, union select column name, null from all tab columns where table the name of the table we found dash dash. After sending it, we get a list of column names for that table. So the process is simple. First, use all tables to find the user table, then use all tab columns to see its columns. Once we identify the username and password columns, we can extract their data in the next step. Now let's go back to the lab and apply these payloads. I use the same union select structure that we tested earlier, where we return the values of B, C, and D, E, F. This time, instead of test values, I insert a real field, table name from the Oracle system view all tables. The payload becomes single quote union select table name null from all tables dash dash. Here, table name returns the names of the tables, and null is used as a placeholder for the second column, since we know the query requires 2 columns. I send the request and receive 200 OK, which means the payload is valid and accepted by the server. Next, I go to the Response tab, because this is where the results of our SQL query are shown. To find the relevant table faster, I search for the word users. The first matches. This is likely a system or administrative table, not the one we need. I move to the next match. The next result is users CMITSX. This looks like the correct table. It contains the word users, and the random suffix matches how PortSwigger names tables in this lab. At this point, we've identified the table that likely contains user data. I copy and save the table name so I can use it in the next step. Now I keep the same union select structure, but instead of listing tables, I switch to retrieving column names. I use the following payload, single quote union select column name, null from all tab columns where table name users CMITSX dash dash. This tells Oracle to return the column names from the table we found earlier. I send the request and receive 200 OK, which means the query works correctly. I go to the Response tab and search for username. Burp finds a matching column, username ECJKSY. I highlight it, copy it, and save it so I can use it in the next step. Next, I search for password. Burp finds another column, password PPEPDP. I copy this one as well. Now we have everything we need, the table name and the username and password columns. I go back to the Request tab and update the payload again. This time I use the data we found earlier, the user's table name, the username column, and the password column. This payload will return usernames and passwords from the user's table. I send the request and get 200 OK. Then I go back to the Response tab and search for administrator. Burp finds a match. Next to the administrator username, I can see a value that looks like the password. I copy this value and return to the application. I click my account and log in using username, administrator, and the password I just extracted. After logging in, the attack is successful. I now have access as the administrator. Before continuing with more SQL injection labs, it's important to understand the basics behind how these payloads work. On the channel, I've already published 2 beginner-friendly videos that explain the core concepts step by step. The first video covers how SQL queries work and explains the fundamentals of SQL injection. The second video explains union attacks in detail, including how union select works, why column counts matter, and how payloads are constructed. I'll leave links to both videos in the description below. If some parts of this lab felt confusing, I strongly recommend watching those videos first, because they explain the foundation needed to build and understand SQL injection payloads. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.